Hello and welcome back to the channel. Today we're going to start a new series of videos about the ARINC 429 transmitter and receiver PCB project. So this will be the PCB we will work with. In the series of videos I'm gonna explain all the details about the PCB. This first video will be just an introduction with a block diagram how the PCB works in general, what are the main components and the capabilities of this PCB. In the next videos we are going to see details about the transmission and the receiving and the circuit, of course. I will post the software and probably the schematics on my GitHub. Anyway, I'm gonna share with you how I did it and the details of the schematics in the upcoming videos. So in order to understand what are the general components here and this and the capabilities of this PCB, let's move to the iPad. Here we are. This is the main basic structure of the ARINC PCB. We have in the center the ESP32S3, very cheap component that you can get from AliExpress around 5-6 euros. It's a very big, capable microcontroller. It has two cores inside that can work in parallel. It can it's a 32-bit architecture, so it's very capable, very powerful and very fast. It will be fast enough to process ARINC transmission and receiving and also in and out to the SIM. So talking about the in-out interface, we can use interface that can be used to connect to the SIM or a computer. We can use the USB because the ESP32 has on board two USB ports. This one of the two USB ports can be used to exchange data with the SIM. We can also use the Wi-Fi because the ESP32 has onboard Wi-Fi. This is another possibility, or which is should be the most the fastest and the most reliable protocol is Ethernet. So the PCB has a capability of having Ethernet connection using an external Ethernet module. And this Ethernet external module, I used W5100. Once again, a cheap Ethernet module that can be found easily on AliExpress for, I don't know, 4 euros maybe. Talking about the ARINC itself, the PCB is capable of doing ARINC transmission high and low speed, ARINC receiving in theory high and low speed, and in theory also two receiving channels. Why do I say in theory? Because so far what I tested and it works. I'm pretty sure it can do transmission high and low speed. It can also do receiving low speed, but I still didn't test the receiving high speed. Why? Because I don't have an ARINC device which does high speed so far, but I hope to do this. And as this project is open source, maybe you can easily reproduce the PCB and test yourself if you have a ARINC high-speed driver available. Also, I didn't test so far the second channel because once again I didn't need it so far because all the hardware ARINC avionics I have, I just used either just the transmission or the receiving only, or transmission and receiving together, but not the second receiving channel. So the one thing I want to point out is that this PCB is cheap. I mean, it doesn't use any expensive hold or any fancy ARINC ready driver. It uses op amps and simple logic circuits, so it's going to be very cheap to get. In terms of the ESP32 software itself, we're gonna see in the upcoming videos we have several tasks, which are this one here basically, which run in sequential or in parallel mode, and this will be managed by the ESP IDF software, which runs inside the ESP32 and operative system, which is going to manage all the tasks, is FreeRTOS, which is the software used by the ESP IDF developing environment. So basically we have let's say 5 pieces of software of tasks. Sorry, we have either the Ethernet or Wi-Fi task. According, if you choose Ethernet or Wi-Fi, you can also have both, but I don't know if it is useful. Then we're gonna have the ARINC transmission interrupt, which is of course going to process the transmission signals. Then the ARINC receiving interrupt task. Then another task which will be dedicated to the ARINC decoding. So the raw bits which are going to be transmitted and received are going to be decoded or encoded in order to have and at the end we have the SIM interface. So this will be the last piece of software which is going to communicate with the SIM itself. Of course, the tasks will have different priorities. Of course, the ARINC TICs and RX are going to be the highest one. The decoding is going to have a lower priority, and it's going to be the same priority more or less with the SIM interface. Of course, in this project there are still open questions. And as the software is free and open source, the entire project actually is free and open source. I hope you can build this board yourself and test it out, because there are still some questions I would like to answer. I, for instance, don't know if the SIM interface that we're gonna see will be good in the long run. I don't know if the latency of this ARINC combined with the SIM interface is acceptable or not. There are a series of questions. I think it will be very interesting to go into them one by one together. So that's all for now, and see you next time. Bye bye.